Karim, have you you gonna show us now the future of the next OM?
Yes. Okay. First of all, thank you for inviting me, and bravo for Paulo. Very amazing work he's done. He said he's very modest. He says that I helped him a lot. It's not true. He. This is a very amazing work he's done, and bravo. So, well, I will be short. It's not very long. I will show you the new features in the 6.19 version. So there are not so much, but one feature which is I think so. First feature I've added is the TTY box. We can type F. We have a undefined. We can type OM random. This is how it used to work. Okay, now you double click and you have the completion feature. So it's a shortcut and very useful, I think. No, it's like I was inspired by the OM sharp environment. Okay, so this one is a feature, and I've told you that I've re-implemented by typing X. We have now the extra palette for the 3 platforms. It used to work only for Mac. So now you can select, change the heads, type text if you want. Okay, set. You have a text. You can move it around if you like to. Okay, etc. This is the palette, and you have also the tempo, which used to be well. This editor, by typing M, we can change the tempo. If we select measure, it's the same editor. Okay, we can change here on the first unit, expressed unit, we can put 75. Okay, set. Okay, and if we are in chord mode, I can also, if I type M, we have, this is the old legacy tempo. I can put here 45. Okay, okay, so this is restored. Another thing which I restored is, like Paulo showed you, if you type T on the thing, tutorials were disabled. Now you have the tutorials back. So if I type T, I must just update the patches. They are not all updated. So I have this here. If I type OM plus, say, I type T, I have a tutorial which will open soon. Okay, okay, etc. These are in complement of the documentation that you will have if you type D. Okay, I've introduced some utilities. So these are some really basic utilities asked by some members. All atoms will check if it's a list with all atoms. So here we have all atoms. So we will have true. Okay. This is a nil because we have one element of the list, which is a list. Same thing with all list. We have nil because all other elements are, we have one element with the list, others are in atoms. Here it's a one atom, it's a all atom list, it's a all list, so it's true. And then we have, I had a request also to calculate the deepest depth of a tree, which you will find is here. Here, 1, 2, 3. Okay, let me, sorry. Well, 1, 2, 3 depth, 1, 2, and 3. Okay, so we have 3 depths here. And this is to find out a member's position. So if we have a, if I go in this list and I want to see this element where it's positioned in the list, it will give me 1, 3. Okay. If I put just one atom, it won't work. Okay. It's very silly. Nil. Okay. Here I will have, of course, 0 position. Okay. So these are some basic utilities. I know we can do it in Lisp also, but for starting user, it's easy. Another one is to remove nth element of list. I will remove the second element, the third, and the fourth, meaning 1, 2, 3. Yeah? Okay, this will remove it to return the list without the nth1, nth2, and nth3 element. It's non-destructive, so because you can usually you can do it, but it's a destructive function. We can now also iterate a list. If we take a list of 6 elements and we want just this list to have 14 nth elements, so it's not like repeat n. We don't iterate 14 times the list. It's just to have this this list iterated up till to have a count of 14 elements. This is very useful when you have, for instance, this list, which is of 16 elements, and another one which is not a multiple. Okay, we will iterate it on, and we can couple each list with a list. The first list with the second can match this. So this is something useful. Sometimes we need to do this. So voila. Another thing is when we have a sequence, a list as a sequence, and we will group, this function will group a same consecutive sequence. So we have here this string, this symbol repeated twice, 5 repeated 3 times, etc. So this will group the lists, the elements that are the same. The same principle with remove iteration. It will remove an iterated element, not a duplicate element. It's not like remove-dup, but iterated just afterwards. So if we have, it will remove Toto, it will remove these 5. It will not remove all the ones. So you have 1, 2, 1, 2, 3, 1, 3. Okay, these are some basic functions added. Now, on request, I've added chord-band-filter. This filtering, chord-band-filtering, why it's you can do it by loop and filter the MIDI sense, but this one works on the objects, so it will preserve the dynamics, and it will preserve eventually. You see, it's like a diminuendo, and it will preserve also if there are channels included. So it will just filter the chords, really, not the MIDI sense only. So we can filter from. We can give in the second input the minimum MIDI sent to filter, and the maximum one. It's a range, okay? So what will be filtered here is it's the medium range pitches, and we have a pass mode and a reject mode. So this is the pass mode. We will only have this range, okay? It's around the C note, okay? The chord filter is different. It will filter specific pitches. found in the chord sec. So if I just put them like that, I will have just these notes will be in pass mode, okay? And here we will have the reject mode. So these notes will be absent from the result. Okay, this was a request, so you'll find them in the score section, in the score functions, chord filter and chord-band-filter. Okay, and then we have a new function that it was also a request by a composer, a friend composer of mine, and I've integrated in OpenMusic. You'll find it in the trees menu. We used to have the rotate tree, so you know how it's supposed to function. But the rotate proportions, it's a special particular rotation, that meaning that the real duration and recalculated afterwards in the quantification, it will rotate the proportion of inside the trees, the S part of the trees. So it's a Fernie-Howe rotation manner. So this will rotate. We have two modes also. We have rotate all the proportions by one. Okay, so we can see here that the rest, which was in the third place, is now in the second place. And we have the other option is rotation by measure. So this will rotate, it will take each measure and rotate it apart. This will give us two different rhythms. Okay, so afterwards I have added a new function that I used to have. It's the sound. This is a sound file, okay, and we can just import it into a BPC here, or BPF library. Okay, so it will take. You can sample it. Let me put this here. We can sample it, let's say, by taking it down to 500 points, like this, okay, and it will give, just lighter resolution. And we have another option here, I think so. It's for the channel. If it's a stereo file, you can choose if you import the left or the right channel. Then we have a new function, bpf-stretch. It's not like bpf scale. This will stretch by a factor of for the x points and the y points. This was necessary. You will see why. So this is the same representation here. But if you look carefully here, the points goes from 0 to 1 and 0 to -1 maximum. And so I needed to stretch the y points to make them more going to 1000. Export-svg. This is not a new function. That's what Pierre Giorgio was asking, but it was not in the menu. Now this export-svg is in the menu. Why? Because it has a lot of options. You can put the points between each straight line. You can define a width, a height, and you can define the margin of your document. And you can, the line size also, the thickness, line thickness. But for this example, we don't need this. I will export it in SVG. svg. Up. I will go to the next screen and show you the result. And I will open it. Will open in Inkscape. Okay, so this is the representation of the. You can change it. You can edit it, etc., etc. You can modify it. Okay, let's say okay. So this is what this was available, but I have done some code with importation, and I will show you later why. So here I have I will show this to you. This is a sketch I've sketched by hand. You know, I'm not a really and I'm not a great artist, so I drew some Bezier points, etc., curves and I mean lines and stuff like that. And then I've imported into a BPC library. And just to show you what we can do with it, so I've here it's just for translating the points for pitches, and this is for it's just a magical trick. It's just for demo. It's not a piece at all. This is just to do modulo 17 of the 16 channels without the 10th, of course, because we don't need the 10th. And we will have this figure translated into a chord-seg with MIDIX channels and offsets, okay, and onsets. Okay, I don't know if you. Okay, this is just to have fun, but originally, okay, I needed to do a score like this, you know. So this is a BPF I've done, and this is a chord-seg, and I needed to include them in a score like this. This is the poly you have seen, and the two examples, the chord-seg notes are here, comes here, and which is not a chord-seg, but it's a BPF doing some statistical points, and this is the BPF will come here in this measure. Okay, so this is exported in LilyPond. Then I won't load my library because it will clash. So this is a statistical cloud. If we take just the points, I will translate them into a BPF like so. Okay, and here we will have a registration, and it will be exported and to give this cloudy thing here. And for concerning this one, it's a BPF. It's a BPF. I've done these BPFs here. This is a library of BPFs. So it's translated again into this. This is the extract here, and it's exported into SVG. And then all these are edited in Inkscape, or you can do it in Illustrator, but I use, I'm on Linux, so I use Inkscape. So these are mainly the new features. I will not talk about bug fixes because there are a lot. And what's coming next, and I will stop here. I've talked last time about the quantifier and the grace note issue, And sorry, also I told you also I will fix. I was planning to fix the tempo issue. You know, with 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 a dynamic tempo issue, which is not that easy. So that's why I've left it alone now. Okay, if it will work, but it will not play as it's supposed to. Okay, so this unfortunately appeared to be it's much more complicated than that. So I must fix it, but prudently, with prudence, deep prudence, because I don't want to break the voice and the classes and keep compatibility. So let's come back to this quantifier, which for the time being I called it cont j. This quantifier will quantify without without errors. I mean, the first error we can see. Okay, if you take these durations, okay, we have 1000, 125, 75. These are all quantified on 60. So what's below 125 will be a grace note. So we have two grace notes here. So in the traditional OM quantify, we will have the 1 minute, 1 second duration. Okay, let me put this like that. Okay, like that, it's better. Then the 125 milliseconds, 75 milliseconds, which is not that. It's supposed to be something else. Silent rest, okay. 125, 1000 rest, and something else. In the second, in this quantification, the new quantifier, it will skip these two grace notes because it will skip this one because it's insignificant. So we will have a correct quantification. Because in the quantify algorithm, there's a problem with the rest quantification, as you will see here. So if we take, for instance, this rhythm structure, and we want to quantify it. So let me put it like that. Let me put it, sorry, like that, the quantification. So in the first one is the original voice. This is the OM quantify algorithm, and this is the quantification I'm working on. So if you up till these two measures, they are both the same. Here we will have first of all we will have a note, a neutral note, which is inexistent here, which is corrected here, and we have skipped notes. So this note here should be an A, okay, but it was skipped because the chords are grace notes, and they are here indicated by red. Okay, so this is it. And if we move on also, we will see that this quantification finishes with the same notes of the original one, or this one finishes here. So we have skipped nine notes because we have nine grace notes. Okay, this was also a big feature, a big request of many composers, they complained that the quantifier didn't accept the grace notes, n'est-ce pas, Alan? Alan wanted also the grace notes. So it's nearly finished. The problem is with the offsets, because I've tried to fix in order that all grace notes play an offset before the real note. But there's a big problem in the code itself, so I must go into it and look carefully. But now, for the time being, it will play as a chord. I am working on a new library which I evoked when Pierre Giorgio asked me how can we export these. We can, of course, like you've seen, export them in SVG, but you can also export them. This is a 3D. You can export them to gnuplot. So I think it's available for the 3 platforms, and we have some preference here. gnuplot. We can the output could be a PDF, SVG, SVG gnuplot style, PNG or JPEG. You can select also the boundaries of the to add margins. You can select also the title and the font if you want. Okay, so let's export this, for instance. It will preserve also the colors. Multi PDF. Okay. So I've written this personally for my thesis. So okay, come on. Okay. I don't know why it's very, very, very okay. Okay, it doesn't want to open. Okay, maybe it's not a PDF. I think I've done a bêtise. No, it's BP. Let's say it's PDF. Okay. Okay. Okay, now it will open. Okay, so this is the same thing, but exported into a PDF. It's useful if you want to include it into a book or something like that. So for the time being, there are in this library. It's not on the GitHub because it's not finished yet, as you have noticed, and I'm planning to also add some LaTeX functions, exporting functions. So I will stop here, and if you have some question, please, I am all yours.